Good afternoon, everyone. In the expert group for slope-intercept form, you guys are my green packet group. You're among a select few that have been chosen to become the experts in slope-intercept form, writing equations of lines in slope-intercept form. So I'm just going to highlight over what your expert group title is. And more than ever, it is really important that you take the time to watch this video, watch it again if you need to, watch it a third time if you need to, because the whole idea is that in a day or so, you are going to actually be teaching this material to your peers. So it's really important that you yourself understand it. So I'm going to take this nice and slow for you, and hopefully by the end of this video, you're going to be an expert on slope-intercept form. So I gave a couple things here in the beginning to read. First, it says you're going to be writing the equation of a line given three different things about a graph or a line. So the first thing is you're going to write the equation of a line given the graph of the line. You're going to write the equation of a line given 2 points on the line. And finally, you're going to write the equation of a line given the slope of the line and a point on the line. So these three items are actually going to go with these three examples. So you see example 1 is going to hook up with the graph of a line. And then as we go on, example 2 is going to hook up with the second bullet, 2 points on a line. And then example 3 is going to hook up with a point and a slope. So 3 examples, 3 methods. Okay, important information. The first bullet here says that the name slope-intercept form, which we call y equals mx plus b, this is the slope-intercept form of a line. The name is not a coincidence. Bullet 2, m in this equation, m stands for the slope, or the rate of change of the line. So that's a graphical clue. So right here, this m right here, whatever number sits in front of the x, right here, that's a graphical clue that that's your slope. And then b, the guy here on the back, the letter b, he stands for the y-intercept. And that's another graphical clue. So this guy on the back, b, and then I tell you here, because when x is 0, y is b. When x is 0, the y value ends up being b. So let me show you that on a bigger scale here. So here's your slope-intercept form. Slope-intercept form. So this is the slope, m. And the b ends up being the y-intercept. Now, we've studied y-intercepts. Do you remember the definition of a y-intercept? It's where the line crosses the y-axis. We let x be 0, and we solve for y. So if I take this equation and I let x be 0, I would have y equals m times 0 plus b. And so m times 0 is 0, and 0 plus b is just b. So the y-intercept is b, the ordered pair. When x is 0, y is b. So this back number here, whatever your equation is, whatever numbers are here for the m and the b, this is your slope, and this number ends up being the location where you cross the y-axis. So having that piece and that piece is going to make graphing really easy when we get to graphing. Okay, so this is your equation that you're going to become an expert on, slope-intercept form. Okay, so let's get into example 1. So example 1 says, write the equation of the line graph below, here it is, in slope-intercept form. So the first thing you're going to do, and eventually when you teach this, you're going to have your students do, is you're going to go ahead and write down your form, y equals mx plus b. And then all you have to do is pick out the m, and we know how to find slope of a line, and you have to pick out the b, which is the y-intercept of the line. So this one is really easy. So all we have to do, okay, let's get the slope. Well, here are 2 marked points on the line. So we're going to have to count the change in y, or the rise, divided by the change in x, or the run. And I'm just going to do that by counting because they gave me a graph. So my rise is 1, 2, 3. So this distance is 3 for every 1, 2, 3, 4 on the x. So the change in y is 3 and the change in x is 4. So I'm going to say that my rate of change is 3 for 4, 3 per 4, 3/4 x. And then my b, my y-intercept. Well, let's look at where this line is crossing the y-axis. Well, you can see it's down here at -5. See? 1, 2, 3, 4, 5. So I'm just going to put -5. So instead of putting plus -5, I'm just going to say -5. And that's it. I've got my equation written. Now, students will often say, well, why don't I fill in a number for the x and for the y? Well, that's a good question, and there's a good reason. The x and the y have to stay open for business. They're in a relationship. And we talked about math being kind of like your human relationships. As this x is changing, y will be affected. And that's what allows us to get to all the different points on the line. For example, when x is 0, so if I made like a little xy table, when x is 0, y is affected, because if I take 3/4 times 0 minus 5, I get -5, which gives me this point down here at 0, -5. But if x is 4, well, if x is 4 on my line here, 3/4 times 4 minus 5, 3/4 times 4, the 4's cancel and give me 3 minus 5, which is -2. So when x is 4, this is -2. That's why I'm at 4, -2 for this dot. So you have to leave the x and the y open for interpretation, open for business, and open for values to be plugged in so that we can create the line. The line that has a constant rate of change of 3/4 and a definite solid y-intercept of -5. See, these are unchanging. These are changing. Okay, let's go on to example 2. Almost done. This one, no graph. It just says, write the equation of the line that passes through these 2 points, -1, -3, and 3, 5, and they want you to do it in your expert slope-intercept form. So they basically want me to do the same darn thing as we did here, only they didn't provide the picture. So when you're not provided the picture, there is another way to write the equation. So again, let's start from our form, y equals mx plus b. You always want to make your students start from that point because this is slope-intercept form. Now here's the cool thing. Getting the slope is a piece of cake because we've already studied how to find slope when we're given 2 points. So we already know that this is an x and this is a y, and that this is an x and this is a y, and that this is the first set and this is the second set. So over here to the side, I'm going to write our formula, m equals, and we know that slope between 2 points is always given by the ratio. This is our per, minus, minus, and then we put our 4 sets of parentheses in. And the formula goes y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So let's follow it. Y sub 2 right here, 5. Put it in. Y sub 1 right here, -3. X sub 2, 3. X sub 1, -1. Now we do the math. 5 minus -3 is 8. 3 minus -1 is 4. And so our slope, 8 divided by 4 is 2. So I'm going to click and drag that up to m. So now your line looks like this. Y equals 2x plus b. Now all we have left to do is find the b. What's the y-intercept? Well, you can take either one of these ordered pairs. It doesn't matter which one. They're both on the line, so they'll both work. I'm going to choose 3, 5, just because I don't have to deal with any negatives if I choose that point. So I know that the 3 is the x value and the 5 is the y. So I'm going to carry those, click and drag these down. So the y value from this ordered pair is the 5. I'm going to replace the y with a 5. The x value is a 3. And now I'm going to solve this equation for my b. So I have 5 here. 2 times 3 is 6 plus b. Solving for b, I'm going to subtract my 6 from both sides. And so b is equal to -1. So, putting this all together, this is not the answer yet. The answer is, you know y is y. We know the m is 2, so y equals 2x. And now comes the b right here, -1. This is the equation that passes through the points -1, -3, and 3, 5. Now, if you're a visual person and when you teach this to your students, feel free to make them do this, okay? Don't let them off the hook with this. But if you would just have them draw a graph. And plot these two sets of ordered pairs, like 3, 5 is simple. 1, 2, 3, 1, 2, 3, 4, 5. So maybe you have them put a dot at 3, 5. And then -1, -3, -1, 1, 2, 3. So you're here. And you know that your slope ends up being 2, right? So your rise over your run is 2, which we can also write, 2 is like 2 over 1, really. 2 for every 1. 2 on the y for every 1 on the x. So if I go 2 on the y, 1 on the x, 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 you see that they run right into the other red dot. So you can see your slope is up to right 1, up to right 1, right? Simple, constant rate of change. But look at where your y-intercept lands. Right at -1, right at the b value that we got. So this is the mapping of this graph and this information. And these 2 points are most certainly on that line. So that's a nice visual to show your students if you'd like to after you get the equation. Okay, and believe it or not, the very last one is actually easier. This one's easier than the second one, and you'll see why in just a second. Example 3 says, write the equation of the line with the slope. Look, they're giving me the slope. See, in the last example, we had to find the slope. We had to do all this side work. Now I'm giving you m. But that passes through the point 5, -1. So I do have a point. I do have like an x1, y1 situation. So to do this work in slope-intercept form, again, you start with y equals mx plus b. And since they gave me m right here, I can click and drag that right down into m. So my next step, y equals -4/5 x plus b. And all that's left to do is solve for b, my y-intercept. And this is where I'll engage this point into the problem. So my y is -1 right here. And my x is 5 plus b. Doing the math here, if you take -4/5 times 5, the 5's cancel. You're left with -4 plus b. And to solve for b, I'm just going to add 4 to both sides. So b will equal -1 plus 4 is +3. So my final equation, going back to this kind of form here, you got to put your m and your b in. So you know your m is here. Now you have your b here. X and y stay x and y. Final answer, y equals -4/5 x plus 3. Okay, you have any students struggling as you're teaching them? What you do is you draw them a graph. Again, do this at the end. Give them a little visual here if you want to, and this will help you too. So they gave me this information that the line is going to go through the point 5, -1. So let me go 1, 2, 3, 4, 5, -1, right there. And the slope is -4/5. So that means that from this point at 5, -1, I go down 4 on the y for every 5 that I go right on the x. Because when I have a negative slope, I tag that negative with the numerator. So I'm going to go down 4. 1, 2, 3, 4. And I'm going to go to the right 5. I should have made this 5. So I should have made this a little bit longer. So 1, 2, 3, 4, 5. So I'm going to come down 4, 1, 2, 3, 4, and right 5. Put me right there. And the opposite of going down and right would be to go up and left. So I could also go up, 1, 2, 3, 4, and left 5. Something's wrong here. What did I do wrong? 5, -1. I go up 1. Oh, I didn't count this. 1, 2, 3, 4. There we go. Okay. I was having a moment where I'm like, oh no, did I do this wrong? I was not counting this as 1. So 1, 2, 3, 4, and left 5. So you can see my y-intercept there cruising through 0, 3, and that matches, see this 3 matches my y-intercept in my line. Okay, so now you are supposedly, well, almost the experts on this. In order to truly become the experts, you've got to do more work. So this is your mastery. You're going to do the mastery on writing equations in slope-intercept form from graphs, from 2 points where you have to engage and find the slope, and then from problems where they give you the slope and a point. So you're going to do 1 to 15 when you get to class tomorrow, and I'll grade it, make sure you're good, and then in another day or so, you will be teaching your group members how to do equations of lines in slope-intercept form. Thanks for watching.